Welcome to this explainer. Today, we're uncovering the invisible, lightning-fast coordination that makes driving an electric vehicle even possible. If you've ever been behind the wheel of an EV, or honestly just watched one quietly glide down the street, you know they feel like a piece of the future. But what's actually orchestrating that smooth, silent ride? Let's find out.
So let's dive right into this by asking the ultimate question. How on earth do the battery, the motor, and all those sensors actually know how to work together without just descending into complete chaos? Think about it for a second. An EV doesn't have a traditional mechanical engine with physical linkages driving the components. No, it's a massive, complex web of electronics. So who exactly is the conductor of this high-tech orchestra?
Well, the answer is the Vehicle Control Unit, or VCU, and it acts exactly like a human brain. Just like your brain takes in information from your eyes, your ears, and nerves, and then fires off commands to your muscles, the VCU takes in data from sensors scattered all over the vehicle. Then, it makes these split-second decisions in real time. It is the absolute, undisputed central controller.
Here's our roadmap for today's explainer. First, we'll meet the EV brain. Then, explore how the VCU thinks. After that, we'll look at a millisecond in action, dive into braking and safety, and finally, map out the EV nervous system. Let's get going.
Okay, so the sheer scale of responsibility the VCU takes on is honestly staggering. It is constantly, and I mean constantly, exchanging information with every single one of these components simultaneously. It's talking to the battery management system, it's checking in with the motor controller, monitoring the charger, updating your dashboard, and sensing every tiny micro movement of the brake and accelerator pedals. It keeps the whole shebang functioning in perfect harmony.
Section 1. How the VCU thinks. Processing the data.
To really grasp how it manages all of this, we need to break down the actual cognitive process, so to speak, of the VCU. Just like a computer processor, the VCU's logic loop boils down to 3 simple continuous steps: input, processing, and output. Let's break those down.
Right, step 1 is collecting inputs. The crucial thing to remember here is that several times every single second, sometimes polling sensors hundreds of times in the literal blink of an eye, the VCU is absorbing this massive list of inputs from across the vehicle. It's checking exactly how hard your foot is pressing on the accelerator, whether you're grazing the brake, exactly how hot the battery and motor are getting, and even verifying safety features like whether a scooter's side stand is down. It's just a relentless, continuous flow of data collection.
Which brings us to step 2, decision-making. The VCU processes all that collected data using programmed control logic, rapidly asking itself a rapid-fire series of vital questions. Is the battery healthy enough to provide power right now? Is the motor temperature staying within safe limits? Is the vehicle actually ready to drive? Based on the answers to these exact, real-time conditions, the VCU calculates the precise torque and power demand needed for that exact millisecond.
And finally, we hit step 3, sending commands. Once the decision is made, the command goes out. Say you've pressed the pedal. The VCU instantly sends a torque request to the motor controller. The motor controller then pulls the exact right amount of power from the battery to feed the motor. The physical result for you, the driver, that incredibly smooth, head-snapping acceleration we all expect from an EV.
Moving on to section 2, a millisecond in action, a practical example. Okay, picture this. You're riding an electric scooter. You want to get moving, so you twist the throttle. Instantly, the VCU runs through this exact safety and status checklist. The throttle sensor triggers a signal, and before it lets you move even an inch, the VCU checks the battery voltage, checks the battery temperature, looks at the motor temperature, and verifies all safety conditions are totally normal.
This brilliantly illustrates the true magic of the system. If everything on that checklist we just talked about is normal, the VCU calculates the torque, commands the motor controller, the wheel rotates, and you move forward. And the truly mind-blowing part, it completes its entire thought process, from your wrist twisting to the wheel actually turning, in mere milliseconds. You don't even notice it happening.
Section 3, braking and safety, protecting the EV.
Now, during normal driving, power flows from the battery to the motor. Simple enough. But when you release the throttle or tap the brake, the VCU expertly manages something called regenerative braking. Basically, it flips the script. It instructs the motor controller to operate the motor as a generator instead. It captures the vehicle's forward kinetic energy, converts it right back into electrical energy, and tucks it away in the battery. It literally recharges your vehicle while you slow down. Talk about a total game changer for efficiency and driving range. But beyond efficiency, safety is absolutely paramount. The VCU is continuously keeping an eye out for abnormal conditions. If it detects over or under voltage, it might proactively dial back the power,
Getting a bit too hot? It senses that over-temperature condition and might limit your speed to cool things down. And if there are critical communication failures, motor faults, or battery faults, it can completely disable vehicle operation. It instantly triggers these self-preservation protocols to protect both you, the rider, and the vehicle from a catastrophic failure.
That brings us to Section 4, the EV nervous system, the CAN bus network.
So how does it talk to all these varied systems? Well, the VCU uses something called the CAN bus, or Controller Area Network. You can think of it as the vehicle's literal nervous system. It's a lightning-fast, highly reliable network that securely shuttles messages back and forth between the VCU, the battery management system, the motor controller, the charger, and your dashboard.
To sum it all up, the VCU's vital role simply cannot be overstated. It receives the sensor information, crunches massive amounts of data, makes split-second decisions, and controls the entire vehicle's operation efficiently. Honestly, without this incredible central brain, the battery, the motor, and the charger would just be a useless pile of disconnected parts, totally unable to work together.
And that leaves us with a pretty fascinating thought to end our explainer today. We've seen just how much work the VCU does to make a standard EV accelerate and brake smoothly. But as our vehicles continue to evolve, as they become highly autonomous and get packed with even more advanced sensors, just how complex and powerful will the VCU of the future need to be to process all of that? It is an incredible engineering frontier. Thanks for joining me on this deep dive into the brain of the electric vehicle.